Welcome or welcome back at C-Square. In this lesson, we're going to talk about composition of transformation. And let's see what that is. You notice here we have this polygon A, B, C, D, and there is no way to just do one transformation, translation, reflection, or rotation to get from here to here. We have to do more than one. The same for this one. There is no way to go from here to here without doing at least two transformation. This is what it is, a composition of transformation. Okay, another example right here. There is no way to do just a translation, just a rotation, or just a reflection to go from here to here. We have to do at least two. And this is a special one. This is called a glide reflection. Glide reflection, like in this case, you will notice first I reflected ABC over the x-axis right here, and then I translate it by a vector 4 and 0 and get this one. Okay, this is what we call glide reflection. Very important in this case, the order does not matter for a glide reflection. In other words, I could have first translated and then reflected. I'm gonna get the same final result. By usual, the order is very important on composition of transformation. Now let's see the first example here. We have this triangle ABC. You notice the vertices, and first we need to translate it by this rule or by this vector and then reflect it over the x-axis. So let's start, and usually that's the way I handle the things. I start with the point A because it's the first one, 2 and 3, and then I will do the first transformation, which is this vector -3 and -1. Okay, and let me keep that vector notation, not parentheses. And how you do that? Very simple. Just do the addition or subtraction. 2 plus -3 or 2 minus 3, that will be -1. 3 plus -1 or 3 minus 1, that will be +2. And now we're going to do the last thing, the reflection over the x-axis. And if you do not remember the rule, then I will suggest you to do one point, like this point, for example. If I have this point, which is 2 and 1, be sure you choose something that x and y is different. And I reflect it over the x-axis. It's going to be here, it's going to be 2 and -1. Okay, so probably somewhere I will say this, xy becomes x and -y for the reflection, right? And that's the rule. So let's apply the rule here, and which says keep the x, keep that -1, and change the y, make it -2. Let's go to point B, and we're gonna do the same thing. We have 4 and 5, and then we have the same rule, the same vector. We're gonna subtract 3, and we get 4 minus 3, that is 1. Subtract 1, 5 minus 1, we get 4. And then we're gonna reflect it over the x-axis. If you remember, if you do not remember, I put the rule right here on the right. X stays, so I get 1, y, switch the sign, in this case becomes a -4. And let's go to C, the last one in this problem, 5 and 2. So we're gonna have the vector again, the rule, if you want to call it like that, which tells us what to add, to subtract 3. I apologize, 5 minus 3, that is 2. And from the y, subtract 1, 2 minus 1 is 1. And again, reflection over the x-axis, xy becomes x and -y, so in this case C prime will be 2 and -1. Okay, I have here the picture. Now let me erase these guys so we can see the picture and see if we were correct. Now you notice this is the original picture, this is the translation, left 3, 1 down, and then reflection over the x-axis, a second, -1. -2, b second, 1n, -4, c second, 2n, -1. So we are correct. So also you can do this problem graphically if these rules do not help you. I put here a theorem which says the composition of two or more isometry is an isometry. And all these three congruent transformation, rigid motion, rigid transformation are isometries. They keep the shape, they don't change the shape. That's the meaning of the word isometry. If you did not hear this word. Let's see one more example. By now you know we have a triangle, 3 points, you can see them, and now we're gonna do a translation by a vector 6 and 1 and a rotation 90-degree clockwise. So let's start with the first point, A, which is -5 and 2, and that becomes under the translation of 6 and 1. And again, let me keep the vector form. Okay, so that will be -5 plus 6, that will be 1. 2 plus 1, that will be 3. And then we have a rotation 90-degree. I'm going to just use a small r, and I'm going to put just a 90 here clockwise. Remember that, around the origin. So I think we're good with this notation so far. Okay, and now if you do not remember the rule, we can take a point like, you know what, 1 and 3 will be fine, will be the point right here, A prime. Okay, and this one is rotated 90-degree, and again clockwise. Clockwise means this way, right? So it's gonna go somewhere here. It's gonna go somewhere here. Okay, and if you have graph paper, you can really do something like this. See if you get the right angle. That will be here, A second will be here, and will be 3 and -1. Okay, so 1 and 3 becomes 3 and -1. So what will be the rule here? Okay, if I have xy, the rotation 90-degree clockwise around the origin will be what? If you notice, y goes first now, right? This 3 becomes the x, this is the first one, and then 1 goes last, but also we need to change the sign. So -x. So that will be the way I will do it. If I do not remember the rule, I'll take an easy point. Eventually that in first quadrant is the best in my opinion, and get the rule. So now let's apply the rule here. So A second will be what? Well, like I said here, we keep the y and goes first, so that will be 3, and we change the x, which is going to become the last guy in this order pair when we change the signs. -1. B, -2 and 1, and then we have the vector 6 and 1. That is the easy part, and I think, and we have -2 plus 6, that is 4, 1 plus 1 is 2. And now this rotation, this one is usually the one that I can get lost also. But again, now I have the rule which tells me, hey, y becomes x, we move it here to x becomes y, and change the sign. In this case, 4 becomes -4. And then we have the last one, C. C, -3 and 4, and again the same rule for the translation, 6 and 1. And we have -3 plus 6, that is 3, 4 plus 1, that is 5. Again, we rotate it 90-degree counterclockwise, no, clockwise, I apologize, C second, and what is the rule? The y becomes the first guy, 5, and the x becomes the second guy, and change the sign. And that's it for this problem. Let's take a look to this graphical approach. This is the triangle we start with. We move it 1, 2, 3, 4, 5, 6, and 1. This is C prime, by the way, you can see it in the here. And then we rotate 90-degree around the origin O. Let's check the coordinate A double prime. Yeah, 3 and -1. That works fine. B double prime, 2 and -4. C double prime, 5 and -3. Again, this one can be done graphically if you don't like the rules. One more example here, similar with the others. We have this point, this triangle ABC, you see it, and we have to do a rotation now around the origin and a translation by vector 6 and 1. So very important, the order. First, you gonna have to do the rotation 90-degree clockwise. Okay, so again, remember my suggestion, take a point in the first quadrant, 2 and 1, for example, rotate it. That should be right here. You notice that will be something like a 90-degree angle, and that will be -1 and 2, and this is 2 and 1. So again, the rule is xy, 2 and 1 becomes what? Oh, and by the way, this is clockwise and I did it counterclockwise, so this is wrong. So where is that point is going to be? If we rotate, that will be somewhere here. Okay, something like this. Use some graph paper if needed, and that will be 1 and -2. So clockwise, I just want to be sure. So xy becomes what? Y and -x. In fact, this is the previous rule. We use it by. Just want to show you one more time how to get the rule if you do not remember. So we're gonna have here a prime, and we're gonna switch these x and y. Y becomes first, and then the x becomes the second, and we switch the sign. 5. Do these two things, switch and change the sign for the x. And now we're gonna go and do the easy one, in my opinion, is the translation by vector 6 and 1. And we're gonna have a second, which is 2 plus 6, 8, 5 plus 1, 6. So let's go to B, which we're gonna do the same thing, -2 and 1. We're gonna rotate 90 degrees, and that will give us B prime. And if you remember, the y becomes x and the x becomes y. I will also need to change the sign. So in this case we have 1 and 2, and then by vector 6 and 1, that will be B second. 1 plus 6 is 7, 2 plus 1 is 3. Let's move to the last point in this problem, -3 and 4. We're gonna rotate it 90 degrees clockwise around the origin. What will be the C prime? Again, switch. So we're gonna have 4, and then the x, change the sign, make it +3 in this case. Two things here. 6 and 1 is the vector, so we have C second. 4 plus 6, that is 10. 3 plus 1, that is 4. So we have here this transformation. This is the graphical way, and we notice A second is 8 and 6, B second is 7 and 3, and C second 10 and 4. And yeah, this was the rotation 90 degrees. And for those who look at here, that's what I meant, 90 degree. You can see the angle here. And then the translation. Okay, a graphical way in case you need it. Let me go back a little bit. Yes, you see it. This is the previous problem. It was the same triangle. The order is important. Okay, very important to do the rotation first and then the translation in this case. Let's go to the second part of this lesson, and now I'm going to talk about a special type of composition of transformation, which is reflection in parallel lines. So we notice we have these two lines here. This line, let's call it L, and this line M. First time I take this triangle, reflect it over the line L, we get this triangle A prime, B prime, C prime, and then this triangle is reflected over the line M, we get this triangle A second, B second, C second. And what is the equivalent transformation we can do in such a way to skip the first reflection? Okay, let's take a look here. That is easier to see it in my opinion. Again, you see a first reflection and a second reflection. Look at here, from here to here, doing one single unique transformation, that is translation. We can slide triangle ABC this way until we get right here. The question, how much? Pick any 2 points like C and C prime, and let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is 12 units. Let's see how much is the distance between these two parallel lines. 1, 2, 3, 4, 5, 6. So the distance you slide the triangle is twice the distance between the parallel lines. And in fact, this is the rule you see here. The translation, we have to do it in case we have a double reflection over parallel lines, is by a vector that is perpendicular to the parallel lines and is twice the distance between the lines. Very important and I think easy rule. Another special composition of transformation is reflection in intersecting lines. So you notice here we have these two lines, DE and DF, you want to call it like that, or L and M. It's either way will be good. First we reflect this triangle over the first line, we get this triangle, and then we reflect this one over this and get this one. And we have the same question, what will be the unique one transformation will allow us to go from this guy to this guy? And that will be a rotation. Hopefully you can see if I rotate this triangle, I go on top of A second, B second, C second. And now what is the rule? You will see right here, the rotation is an angle twice of the angle of intersection. I said that here. Okay. So remember these two composition of transformation, reflection over intersecting line, this one, and reflection over parallel lines. And also on my description you will find 2 apps and 2 clips that will help you to understand more if that is needed. Finally here I said, as you notice, translation and rotation can be described using reflection. So everything in this world of composition of transformation can be described using only reflection. That is very cool and very important in my opinion. Right? Anything I can do, it can be just discussed as a sequence of reflection. Okay, now let's take a look to this example. Reflect each figure over the given line and describe a single transformation that maps on triangle ABC on triangle A prime, B prime, A second, B second, C second. I'm gonna answer to the last one. If you remember, we reflect over parallel line, so that will be a translation by a vector of 2 times 4.8, this 4.8, the distance. Okay, and the direction will be perpendicular on the line. Okay, and that will be here 9.6. So for this point B will be something like this, 9.6 units away, somewhere here. I'm gonna try to get it graphically. B second. Okay, that is the idea. That's the simplest part. Yes, this double reflection is equivalent of a translation. Now I'm going to try to do the reflection, and I'm going to do the first one. You notice how I do it. Perpendicular line. Try to have equal segments. So this is going to be congruent segment, in fact, C prime. Let me erase now this segment, and we're going to do the same for B perpendicular here, and I think somewhere here is going to be B prime. What about A prime? Very similar. Of course, a ruler, a protractor, things like this will help you to get a better idea. Compass also, right? But that's it here. Something like this is the reflection over the line DE. And now we're going to reflect it one more time. I think this would be C second. And A seconds should be somewhere here. And then B second. I guess somewhere here. Again, a ruler will be helpful here. And you notice A second, B second, C second, this triangle is a translation of the original one. Translation by a distance that is twice 4.8, so that will be 9.6. My very next example is about this one. We have the triangle ABC. We want to reflect it over this intersecting line, and want to get the triangle A second, B second, C second. So this one, if you remember, will be the equivalent transformation will be a rotation around point D. And now you see this 45 degree, we are going to have twice that angle. So that will be 90 degree in our case. Okay. So you want to skip, you can rotate point C 90 degrees, something like that would be somewhere here, and so on. That is the simple part. Let me try to do the picture now, and I'm gonna start to point A, even though it's the furthest away. So again, I'm gonna try to draw a perpendicular line on the first line, and sometimes this can be tricky. You can have overlap triangles. So I think that would be good. B somewhere here is not perfect. I'm just trying to sketch. And this one, I guess it can be even somewhere here. Okay. Again, on my description, you're gonna find an app, and you can play and you can see those things. And then we're gonna reflect over the line L. Based on what I said, I can be wrong. I'm gonna say again. Let's take a look here. This is going to be perpendicular. It's going to be somewhere here. Okay, this is C second here, and this will be B second, and this will be A seconds. I will say something like this. It doesn't look like a rotation in my case, but again, I'm gonna say try my app. Let me try one more time. I'm gonna try to be better now. Like I said, it's not an easy task to do it. We can try it one more time. Okay, so one more time, I'm going to start with point A. This one has to be 90-degree angle. And hopefully, I guess, is that good enough? I hope it is good enough. Oops, let me go back. I hope it's good enough to be A prime. You know what? Let me A prime this one. Let me reflect this guy again, 90-degree angle. That will be pretty close right here. And that will be A second. So again, remember, I'm trying to see that rotation. B, again, right angle here. Oh, I forgot to say here, right angle. And this is shorter than the previous one. It should be somewhere here. I think B prime, and then something like this. This is going to be a little bit longer, and hopefully something like here. Okay, now we can take a look to this A second, B second. Does it look like a rotation? I hope so. Okay, and then we have one more C. This is C prime. No, this is not C prime. This is the tricky one that I was kind of. Do you think that is here? You can. I don't know. It might be good here. Maybe it's going to be even on the line, but C prime, C second should be somewhere here. C prime somewhere here. Okay, very close to the other line, and hopefully now I did a better job, and you can see that rotation of 90 degree around point D. Final part of the lesson will be about congruency. Congruency can be defined using this composition of transformation. For example, you notice on this slide here, how do I go from this guy to this guy? You can see it in my picture here. First, I reflect it over this line, L, and then I wrote it around this point, and I get this. If you have a composition of transformation that allows you to go from one position to the other one, to move this on top of the last figure, that means those two shapes are congruent. Very important. I put here this theorem: two figures are congruent if and only if. Very strong statement here. Goes both way, biconditional. There is a sequence of one or more rigid transformation that maps one figure onto the other. Like in this case, yes, we have. Let's see last example in this lesson. You notice here we have a triangle ABC, and we want to prove that triangle ABC is congruent with triangle MNP. If you've never seen this sign, that's the meaning. And we need to find a composition of transformation that maps triangle ABC onto MNP. I'm going to try to find one, but I'm going to say something. You can find a different one because it's not a unique transformation that maps triangle ABC on triangle MNP. So first of all, I'm looking and I notice the orientation of the triangle ABC. A is down here, and then M, which is the corresponding part. It looks like that. So how do I get this change of orientation? It has to be a rotation in my opinion. So if I rotate this point A around point O, 90 degree, I should be somewhere here. If I rotate point B around the origin, this is -3 and 4, so that will be 4 and -3 is going to be somewhere here. And then point C, if I rotate around the origin, -1 and 4, that becomes 4 and 1. Okay, so this is one thing that I can do, is not the only one. Again, I'm going to say that I'm going to rotate triangle ABC and get this position, right? And how do I go from here to here? That's a simple translation. You can notice we can move one right and 1, 2, 3, 4 down. So let me write here, one way, because there are multiple ways, will be first, rotate triangle ABC 90 degree, and we move this way, right? Clockwise. Now we have to give the center of rotation, rotate triangle ABC 90 degree clockwise around origin. Okay, so that will give us this triangle. Let me call it A prime. All right, B prime, C prime. Okay, and I'll put here, that will give us the triangle A prime, B prime, C prime. And then how do I go from this A prime, B prime, C prime to M and P? I will do a translation. Second, translation, triangle A prime, B prime, C prime, by the vector or by the rule. Let's write in this format. XY becomes what? We're gonna move one right, so x plus 1, and we're gonna move 1, 2, 3, 4 down. Okay, or if you want, you can write the vector here, 1 and -4. Either way will be good. So yes, now we know, we found the sequence of transformation. We know these two triangles are congruent, they have corresponding congruent pieces, because congruent, this transformation preserved distance and angles. You can see that in my picture here is the same idea. You can see the rotation and then the translation. And I think that's all what I have in this lesson. If you enjoyed this lesson, don't forget to click the like button and come back and see square for more help. Thank you.